Good afternoon, everyone. Let me just get set up here in my working file. Desktop, let's spell. And what I'm going to cover today is, let's jump right in to our desktop and the 6-week classes. So what I'm going to cover today is format string vulnerabilities. And topics we're going to cover in this class are going to be what are format specifiers, format string vulnerabilities, reading any arbitrary memory address, understanding direct parameter access, and actually we'll be doing some writing to arbitrary memory addresses as well. So format specifiers in C are placeholders used in functions like printf and scanf to indicate the type of data being processed. They start with the percentage sign and are followed by a character that specifies the data type. And we'll get into some real world examples. They ensure correct data formatting during input and output operations. So here are some common format specifiers. We got D for decimal integers. So when you're printing numbers without a float point. So we have unsigned decimal integers right here. Here we have floating point numbers. So this is when we get into like things like pi. You can also do floating point 2 decimal places. String you'll see a lot, and especially in this lesson, you'll also be using hexadecimal in the lowercase. So these are format specifiers. So what we'll do, we'll jump right into our codes, and I'll start showing you what these format specifiers look like, and then we'll jump into format string vulnerabilities. So here's a bunch of print statements here. We have an input. So you can see print A, we have an integer A declared here. Int A is D for decimal, and it'll print the decimal. We have A is X for A, and it'll print the hexadecimal. I then have what the fuck %n, and %n counts the bytes and writes how many bytes this is into A. Then we'll print A is the decimal and A is hexadecimal again. Okay, so a little childishness just to make this stuff a bit more fun. So let me just get over here and let's run first. And as you can see, A is 0, A is 0 in hex. What the fuck? A is 11 now. A is B now, because B is the hex of 11. 10 is A, right? So that's what format specifiers are. Now, if someone leaves format specifiers out, it can become a pretty big vulnerability. So let me just haul up this game here, and we'll play this here shortly. What I have here is a printf statement, and as you can see, it has no format specifier in it. That's a vulnerable function, and this here is a vulnerable usage of that function. So what it would look like if it were actually protected. Let's have a look at this game 2. And as you can see here, there's a string format specifier right here at the beginning. So what this does is make sure that my user input is sanitized and it's only going to print the string usage. So what we can do is let's open up our game here. So first we'll open up game 1, and it says to enter a string. So I'm just going to put in a bunch of A's, but then I'm also going to put in some of these format specifiers. Let's just see what happens. So as you can see, now we have now the program here puts in a debug info of where the secret address is for a secret stored password. We'll get into that in a second, but what I want to show you is this is actually leaking memory addresses right here off the stack. So now let's do game 2, and let's put in the same sort of input, but this time, whoops, this one has the format specifier of string. And as you can see, this is all that gets printed, A and the X's, because it's only going to print in the string format. What we did here was a format string vulnerability. So let's have a look at game again. And let's put in a whole bunch of format specifiers here, and let's put a dot in between it, because then that way we can see what addresses are what here, instead of it just being a big run together number. Whoops, sorry, did it in the wrong place. So let's try that again. %x, %x, %x. And as you can see, these addresses are all spaced out here. So now we have a super secret password is stored at this address here. So let's run this game again, and let's put in a bunch of specifiers and see if we can find that. Six, 7, 8, 9, 10. Let's try 10 in this one. And as you can see, this address right here is being reflected right here. So this is where our super secret password is in our program. So we can look and see 1, 2. It's 2 back from there. So like, let's take our input. And what we'll do, we'll use another format specifier now. Let's run game again. And we'll put this here in. And the second one back, whoops. Bunch of gibbly guck there. This second one back here, let's put a string, and we'll cover this one up. And as you can see, it's dumping super secret 123 as a password string. So let's go have a look at our program, and I can assure you that here in our game, here's the character secret password, and it is super secret 123. So this is the basis of format string vulnerabilities, where it's going to leak memory, and this is from bad programming. So if a programmer forgets to put it in or doesn't know, they're brand new programmers. That's why WordPress is always messed up, because of new programmers not knowing all the rules of security and what can happen. And this one here can happen. So what we'll do now is we can also read. Let's jump into, so we went over what format specifiers are, what format string vulnerabilities are in the very basics. So now we're going to read any arbitrary memory address. So let's have a look at this read program. Is another one I have written here, and it's basically an input, character count, argument vector, a small buffer, stir copy, which is vulnerable, of course, but we're not doing a buffer overflow, and the printf here, and it doesn't have a format specifier in front of it. So this one's going to be vulnerable to string vulnerabilities. So what we will do is let's play around with this read game I have made. So 6. So let's do read, and let's put in some format specifiers for arguments here, because we know it is vulnerable to this. So I'm going to put in, let's put in 5 of these. And as you can see, it's leaking information. So like, now if I want to read any arbitrary memory on that stack, what I'll do is let's put in a whole bunch of A's. Now let's see where that is reflected in our code. Whoops, let's pull this format specifier back a bit, put a dot in here. So as you can see, our A's is being reflected back to us here. So what I'm going to do, gdb/q read, let's just jump in here and let's set a breakpoint at main. Whoops, breakpoint at main, and let's run. And what I'm going to do, I'm just going to grab some environmental variables here that we can read. So finding our environmental variables is pretty easy. We examine 50 strings from ESP plus 0x, let's say 250. See if we can find them there. So here's our environmental variables, and of course environmental variables only work in this terminal, not in another terminal. So let's just grab a couple of these just for demonstration purposes. So now I have that input reflecting back to me. So now as an attacker hacker on the outside, and this is sitting on, whoops, this is sitting on someone's server. Now, I'm not going to have access to the binary, of course, to go in and get these, but what I can do is start reading just various parts of the stack until I figure out where things are, and that can get real dangerous real quick. So let me show you how to be dangerous. So the first thing we're going to do is read. We're going to put a print F and put 4 of these in. So let's put in our first address here. So 4E and I F4 FFBF. And then I want to put in format specifiers. So let's pretend now, the only reason I jumped into those environmental variables, I want to show you that you can read just arbitrary memory. And I know there's going to be strings at these memories, so it'll be a nice way to show you guys. So we know the AAAs were being reflected back to us. So now whatever address we put in is also being reflected back to us right here, okay? So now we can start, as attackers, start going into this and saying, okay, well, what string is at this? And as you can see, this is our shell environmental variable, and it's showing bin bash. So cool. So as an attacker hacker, you're not going to have access to the environmental variables and such as we did, but I'm just using this as a demonstration that you can read any arbitrary memory spot. So let's, this one's F3 and E2. So let's just switch this up a bit. E2. Okay, so let's have a look at this one here. And as you can see, light DM data VBox user. So this is another environmental variable, and we're reading direct memory leakage all through the input here, all through this printf statement. So this is a string vulnerability, a format string vulnerability. So that's the basics of how to read. So do I want to save? No, I don't want to save. So what we'll do next, we'll get into the writing variables onto the stack. So what I'm going to do right here is, I did make a diagram for this, but I'm not sure if I imported it. I got my class tomorrow, so just let me, yeah, it's here. I haven't imported it in yet. So this here is what we're going to be doing, and we're going to be single byte writing with %n. So this is an example of an address that A is at. We have A set for 6 or 0. I'll see in a sec. Either way, what I want to do, I want to show you guys that we can not only read any arbitrary memory address, we can also overwrite that memory address. And what we're doing here is I'm going to rewrite whatever A is. I'm going to put DDCCBBAA into it. So the way we do it is we start at D0, we put in D1, D2, and D3 addresses with this junk in between. And all junk does is keep everything aligned in between. And we'll put AA into the D0 address, we'll put BB into the D1, and we'll put CC into the D2, etc. So that's what we're going to show you how to do next. So let me just jump into our write file, and I'll show you what our write file is. So it takes an input, again, a buffer. Here's our static int variable A, and we have it set to 6. So what this is going to do, it's going to print, and here's our vulnerable printf statement. It's going to show the value of A for us. It's going to show the address of A for us. And then it's going to print the value of hex. So we're going to change this value of hex to BB or DDCCBBAA. And it's fun to do it. So let me just jump into this here. So the first things first, we got to run this write program. Let's run it with some A's in it. So as you can see here, the value of A is 6. The address of A is this. So that gives us our place to start overwriting this. And the hex value is, of course, 6. So let me just open up my mouse pad for this one. So first thing we're going to do is start writing our exploit here. So printf, and then we're going to go 1, 2, 3, 4, JUNK, 1, 2, 3, 4, JUNK, 1, 2, 3, 4, JUNK, and finally 1, 2, 3, 4, and there we go. So now we have our print statement done. We're going to %x, and then %x, %n, and that's where we're going to start writing in. So now the first address we have here is 2C, A0, 04, 2C, A0, 04, and then 08. And then, so the next one would be 2C, so it would be 2D, A0, 04, and 08 in our junk. And of course, the next one is going to be 2D, A0, 04, 08. And then our last one here is going to be, oh, wait a second here. We messed up 2D. That one's supposed to be 2E. And then finally over here, we're doing 2F, A0, 04, 08. Okay, so I think we got that much. So now what I want to do is I want to change this address to AA. So what I'll do is open a new terminal, gdb/q, and let's do print 0xAA in decimal. So that'll be 170. So we're going to have to do some messing about here to get this to work as we want. So 170, and we'll start there. So let's copy this. And let's do write and put this argument in right here. So as you can see, it did overwrite our address, but not exactly as I want it. So we have the value of 216 went in here. So what I'll do is we have 216 print 216 minus 170 equals 46. So 170 minus 46 is, of course I forgot to hit the P, so 124. So let's go back and let's get back to our exploit here. And 124. So let's try that again, and we'll put in 124. And as you can see, our first address is overwritten with AA. Perfect. That's what we want to do. So let's get BB written in next. So as you can see, this is the way we write. We write to our terminal here. So it's going to be %x, %n again. So what I'm going to do is 0 print 0xAA or BB minus 0xAA equals 17. So I'm going to come down here with 17. And that's what we're going to put in for our next input to try to get BB written into this address. And as you can see, like clockwork, BB. Okay, great. So let's go up and let's take, so now we're going to take print 0xCC minus 0xBB. And we got 17 again. So let's PUD percentage 17x percentage n. So this is going to overwrite our third address. And as you can see, it's written CC. So now all we got to do is our DD. So this is how you overwrite memory through this format string vulnerability. It's amazing. It's so much fun. So 0xDD minus 0xCC. And it doesn't know what I'm doing because I forgot the P. And it is also 17. So let's put 17 in as our last percentage 17x percentage n. And let's put that in for our last input. And as you can see right here, DDCCBBAA. We totally overwrote this memory address with what we wanted via all we're doing too is we're going through the printf statement. So if this was on a server somewhere, we're overwriting stuff right on the server. I'll get into a little more exploitation with this, but this is my first class I'm putting together on format string vulnerabilities. It's a little quick one, and hopefully you guys enjoyed, and I'll get chatting to you guys soon. Bye.